The terminology of the subject electrostatics. Knowing the terms which we come across in the study of a subject is called as terminology. We have so many terms in the subject. Knowing the meaning of the terms, the definitions, the mathematical definitions, that too vital, leading to the depth of understanding. Let us take up the terms one by one. The terms which you come across is one is relative permittivity. It is called dielectric constant of a material, dielectric constant of a substance. What does it mean? It arises from the concept electrostatic force. The electrostatic force, which may be the attraction or repulsion between the charges. Here the force is repulsive force. The force is repulsive just because same charges. The magnitude of force, electrostatic force, it is depending on the two factors in accordance with the Coulomb's law. The factors are these two factors: the charges, the distance of separation, that is directly to this and inversely to this square of distance of separation. When you look into further about the concept, this electrostatic force is not only depending on these two factors, it is also depending on one more factor, that is a constant here we have taken, that is a Coulombic constant containing 4 pi epsilon naught. Here, if any substance, if no substance present in between these two, or the space is empty or space is vacuum, no material present, then the force exerting or force experienced between these two charges is the maximum. That is empty space. The constant containing this value, that is called the permittivity of free space. The value is estimated like this using experimentation. If you place some materials, that is a material medium, if the space contains or if you introduce some some substance into the space, which may be any material, atomic substance or molecular substance, or a material in the form of gaseous state, liquid state or solid state, any substance, in between that is in this space, that material actually will reduce the force, electrostatic force. That is reduction. How it is estimated? What is the reason for reducing of this force? Because every material has its own electrical property. That material, permittivity of the material. It is also called permittivity of the material or the substance. Meaning, the material will permit, the substance will allow or permit its own electrical field, its own electrical force, that material force, electrical force of that material, which will actually oppose this electric force, That is the concept that is we need to understand. Electric force. That is the amount of electric force reduced because of the presence of any substance over here. It is called relative permittivity. Relative permittivity. How do you calculate? How do you understand what magnitude the force is reduced? Because presence of the material, it is known as dielectric constant of the substance. How do you calculate those values? Experimentally, we have evaluated that is epsilon naught for empty space, epsilon m that is medium for any material medium of any substance. That is for water we have found this value. For a material like glass, solid material, for one particular glass this is the value of found. Epsilon material for glass, epsilon material for water. Similarly we have epsilon for what is that? M for all the substances. So you have found these values in literature. That is done by experimental evaluation. This is there. And the unit of this epsilon is this. Coulomb square per Newton per square meter. That is in SI unit. Take the list of all, that is literature values is available, experimentally found values. It is possible to find these values for different substances. Take the list and do the calculation. What is the calculation? That is F naught when the space is empty. That is Fm when the space is filled with material, some material medium. This value is greater than this value always. Take the ratio of these two forces. This force is always less than this force. Ratio of this. Dividing this by this. This will cancel, this will cancel, these two cancel, these two cancel. Remaining what is that? This by this. So this left hand by left hand, this side, this divided by this is equal to epsilon m divided by epsilon naught. That ratio is called as epsilon r. It is known as relative permittivity. It is also called as Bernoulli constant. Know these values for different substances. Take the ratio, do the calculation. If you do so, for water it is found to be 81. Permittivity for this material, this by this, you get this. Permittivity for this glass material, this by this, gives this. Likewise, epsilon r, relative permittivity for different substances, when you do so, we get this value for water. That is called as relative permittivity or dielectric constant of water. With this value, what can we understand? Right, the relationship. This value, ratio is this, it is 81. From this mathematical expression, rewrite this as this, you can write it as cross multiply. Either these mathematical expressions. The same thing as, what does it mean? If you put water in between these two charges, liquid water in between these two charges, electrostatic force, that is F, is reduced by 81 times. If you put water. If you remove water, it increases by 81 times. Remove water, put water, decrease the electrostatic force by 81 times. Remove water, increase electric force by 81 times. That is called as dielectric constant of the material. Like this, we have calculated epsilon r for different substances. It is for the glass 7. It means if you put a glass like this, electrostatic force, that is F, reduces by 7 times glass material. If you put what is that air in between them, electrostatic force reduced by 1.006. It is not of much effect. Almost air, that is gas, will not reduce that much. It is almost same. There is relative permittivity. Says that is permittivity of the air and empty space almost same. It is little bit more than this. That is all. And likewise, we have calculated the dielectric constant for different materials. For the conducting material, a very good conductor of material. That is epsilon r is infinity, infinite value. Epsilon r, relative permittivity is infinite value. That is infinite value means that is force is reduced to 0 almost. if you place a metal, good conductor of material, that epsilon r represent the electrical property of the materials. That is, metal is a good electrical property. That is, the electric constant represent the materialistic electrical property, which is more electrical, which is having more electrical in nature, which is having less electrical. She said insulator have less and conductors have more, like this. So on the basis of this, you understand the meaning of relative permittivity. What is meant by relative permittivity? Relative permittivity is how much the electric force is reduced. How many times the electric force is reduced is called relative permittivity or relative constant. Next, it is a comparison between two forces, electrostatic force and gravitational force. Electrostatic force is Coulomb's force. It is Coulomb's law. Gravitational force by Newton's law. That is equation of Newton's law, equation of Coulomb's law. Electric force because of electric charges, that is gravitational force because of masses. When I talk about a charge, electric charge, all charges come with a mass. However small is the mass. Mass is however small. Every charge comes with a mass. Example, if you talk about the electron charge is this. So small is the electron. Electron mass is this. 10 to the power of minus 31 kg, very small amount of mass. Whichever amount is however small, but every charge has some amount of mass. That mass produces some force is called as gravitational force. That is gravitational constant. The value of gravitational constant is going to be in SI unit. The value of Coulomb's force is going to be in SI unit is this. And the comparison, what is that? Let us do the calculation. What is that? If you take any two particles, let us take the particle like electrons. Between electron, let us compare this force and this force. Calculate this force for the two electrons, calculate this force for the same two electrons. Using mass, using charge. Both electrons have same mass, same charge, both electrons have same mass. This is gravitational force, this is one. Take the ratio of this, this by this. So that will cancel, r square also cancel, this divided by this. K, this into Q1, Q2 means whole square for electrons. Divided by this into M1, M2 means whole square, that is mass of electrons. Simplifying, we get this value. Ratio is this. We get this ratio. Fc by Fc is equal to 4.17 10 to the power of 42 between electrons. This value, very high value. Do the similar calculation for between protons, two protons. Difference is mass here, proton mass here, it is 10,000 times more than this. Proton mass is 1.67, it is not written, 1.67 into 10 to the power of minus 27 kg, proton mass. Proton charge remains same, this is the same chain, same charge. Proton, electron, same charge. Electron carries negative charge, proton carries only positive charge. But magnitude of charge remains same, Coulomb. Substitute in these equations, find the value, that is Fc by Fg. We get this value between two protons. 10 to the power of 36. If we take proton and electron, between electron and proton, do the same calculation. This force and this force, the ratio. Taking the proton and electron charge is same. Proton mass is proton mass, electron mass is electron mass. Do the calculation, you get this value. That is between proton and electron. 10 to the power of 39. Fc by Fg, look at that ratio. This is the range. What is the range of that value? 10 to the power of 40 AD. 10 to the power of 40. Look at the 10 to the 40 means, what is the value of 10 to the 40? Very big value, that is 40 zeros. You cannot read that value, that magnitude, the ratio. It means Fc is equal to 10 to the power of 40 into Fg. Electrostatic force is, it is greater, or electrostatic force is 10 to the power of 40 times greater than this Fg, that is gravitational force. On comparison, this is abnormally high value, comparatively very high value with gravitational force. That is just comparison. If you have the charges, you need that you know that all charges will come with the masses. If the mass is there, one more force is there, that is gravitational force. If charge is there, Coulomb's charge. So both the forces are acting between the particles. The comparison is 10 to the power of 40 times. Nearly very large difference is there. Just a comparison. Next is the other points to be discussed, other terms to be discussed. For this, I need to stress upon that what is electric what is electric field. If any charge, that is individual charge, is present in a space or existed in a space, isolated charge I say, either positive charge or negative charge, any isolated charge which is present in a space, a positive or negative charge, sometimes it is both positive and negative charge present in this space. If that is there, what is that? Every charge creates its own field, electric field. That is the form of electric lines of force, electric field. So every charge creates its own electric field around the space. Symmetric it is, spherical shape around some space, three-dimensional space. So that is filled with electric field. Every charge creates its own electric field around that, what is the space around it, charge. That is called as electric field. We can visualize electric field in form of electric lines of force like this. You see that this is electric lines of force with respect to positive charge. If it is isolated, in the isolated state, only positive charge is present in the system. If negative charge present in the system, this is electric lines of force. The direction, because electric field, electric force or electric lines of force have directional in character. This is the direction of electric lines of force. Radially outward in three dimensions all around. Some space, the electric field around it, radially outward, direction of field. That is radially inward, if minus q, negative charge. The charge is negative, radially inward like this, electric lines of force. That is coming from the infinity to this point. This is commencing from the point, this charge point to infinite distance, the radial. So radial distribution of electric lines of force. It is inward, it is outward. If they are in the isolated state, that is one way. If the charges are, two charges are present in the system, one is positive and negative charge, the lines of force, electric field are not like this, They commencing from positive, ending at negative. That is lines of force, that is the arrangement or distribution or what is that, the electric field around the space in which the two charges present. That is distribution of electric field. The space is filled with electric field like this. That is the vision. That is, we can't see, but we can, that is, feel like that. We feel that. We sense that electric field by using instrument. That is sensing of electric field. That is the electric lines of force. That is the pattern of electric lines of force commencing from this ending at this point. Plus q minus q. That is a representation of electric field in the system like this, in the isolated system like this, in the system like this. That is the electric field. Whether the electric charge is single or many. If the electric charge present in the system only one charge, be a positive or negative charge, it creates its own electric field around it. If the system contains Many electric charges, multiple charges. What is multiple charges? More than two charges, maybe positive or negative. Two charges, or three charges, or four charges, or 20 charges, or n number of charges. The system containing. That is, they have the space, they have their own electric field, entire field. Net electric field is there. Electric field is created. In that electric field, whether the system containing single charge or multiple charge, in that electric field, we need to stress upon the important terms. What are the important terms? The terms are electrostatic force, electrostatic field, electrostatic potential. The symbolic representation is F, that is arrow, E arrow, and V. These two are vectors. These two have both magnitude and directions. They have magnitude and directions, but this has only magnitude. Potential has no direction. This is scalar potential. This has directional vectors. So F, capital E, capital, that is V. This we need to understand the meaning of the terms in electrostatics. At every point, we can define this in the electric field. It may be a charge containing single charge or multiple charge. That you need to understand. Mathematical definition, very important one. That is, let us write the definition of this. That is in the system containing only single charge. First, you talk about the system containing single charge plus Q. Here the charge is plus, the magnitude of charge is Q. And to define the electric, that is, define these quantities at this point, let us take some ideal charge. What is that? A unit positive charge. The point charge like this. This charge is Q naught. This is also called test charge. This is known as test charge. And this point charge has assumed that as a magnitude, that is Q naught. And this charge should not create any field around it. So the point charge is so that does not create any field around it, but the field created only by this charge in the space. That is the idea. That is the point I have chosen. You like any point on this 3 dimensions, any point in the space. You can take any point. This is one point I have taken. This point and this point. Let us calculate the force. This force is directional. This is the force of direction. If it is positive, is negative, this is the force of direction. At this point, let us calculate what is force using Coulomb's law. That is easy. Coulomb's law. At this point, the force of what is electrostatic force at this point is given by, that is F, K into this charge divided by R square, distance of separation. So is R is the distance of separation between the center of this charge and this point, that is R, Coulomb's law. Magnitude of force, this, and this has a direction by unit charge, that is unit charge position. So that is positional vector. That is with respect to what is that vector, this represents with reference to what is that reference value, that is origin. In the previous class I explained what is that unit charge represent direction of the vector. That is pictorially we cannot represent here. In the last class I used pictorial representation of direction of the vector, position vector of this vector. Represent direction of this vector, unit position vector. That is the amount of what is that? That is F at this value. That is a mathematical definition of this. Magnitude, this value represent, this value, this mathematical symbol represent direction at this point. Let us define, that is another quantity, electrostatic field E at this point. So what is electrostatic? Define the what is E? What is electric field? Electric field at the point is given by the definition, the force by charge. Amount of force by unit charge. amount of force at this point, electrostatic force at that point divided by the charge. So you can do the calculation of this charge at the point using this formula. There is a definition formula, mathematical definition. For that, substitute for F. What is F is given. Do the calculation. Substitute for Q. At this point, what is Q? Q naught. So this is F divided by Q. Simplify, you get this. This Q naught cancel. K into Q divided by R square. Magnitude of electric field into direction of the electric field. Unit vector, the same unit vector. That is, what is its value? K Q divided by R square into unit vector. E is the field. What is that? Electric field at this point. That is how we estimated by mathematical formula. And this is because of this using equation you can write this. And you know that electric potential, what is electric field? As the point moving away from this point, as the point moving away from the charge, that electric field decreases. That is, magnitude of this value decreases as the point is moving away. That is, as the R value tends to infinity, E value tends to 0. As increases, decreases. As it increases the maximum, it decreases to minimum 0. That is the limit of the function. That is what represent. That is the unit vector. In the last class I explained it, so that is clearly about this. That is a vector direction with reference to a reference point. That is the magnitude of the vector. That is unit vector direction. Represent the direction of the vector. And in accordance with the definition, that is Newton per Coulomb. Amount of charge, amount of force per unit charge. In SI unit, Newton per Coulomb. That is a magnitude of electric field at this point. So that is definition is over. Let us now move on to the next definition, that is potential at this point. For this, to define the kind of potential, let us write this mathematical relationship from the electrostatics. That is a differential equation. So what is the differential equation says that? That is electric field. Electric field is always equal to what is that V? V stands for potential, electrical potential. It is the rate of change of electric potential with R. Rate of change of electric potential with R. Rate of change of potential with R. That is, minus means the potential decreases with R. Rate of potential decreases with R. As R increases, potential decreases. Minus represent decrease in potential with R. That is a differential form. That is the definition is called electric field at every point. Using this, let us write the mathematical definition for this. Rewrite this equation as this. Because you have differential functions. Eliminate the differential function using integration. Integration of the left hand side, integration of the right hand side, integration of this is V, integration of this is R minus R. So that is V is equal to, so in the way V is equal to ER. V is equal to ER. Let us not worry about this minus at this point. V is equal to ER. What is the potential? Electric potential at this point is equal to field into R. Product of field into R, that is distance of circulation. And substitute for this. This value is already known. This is the one. This one. So without unit vector, because it is not a vector, potential is a scalar. So magnitude of this E into R, simplify one R cancel, Q K by R. That is what is called potential at this point. So mathematical expression K into Q divided by R, that is Coulombic constant into Q divided by R, is a potential at this point. V is a potential at this point. The alternate definition for the potential is this. V is equal to W by Q. V equal to W by Q. What is W? That is work done. What is Q? Charge. So Q is equal to 1 unit positive charge or unit charge. Amount of work done on the unit charge. What is the amount of work done? Where the work done is done? Where the work is done? Here the point I am talking about this point. If the point is at infinite distance, if the point is at infinite distance, you have to move the point. What is the amount of work done? Because here you have to do some work to bring the point from the infinity to this point. Because it is moving in this point. What is this in this direction? It is moving. What is against it? Against this field, you are making the point move from the infinity to this point. That is, we need to do work. So it requires always, if the point is at infinite distance, it requires some amount of work to be done to move from the point infinity to this point. That is called as amount of work done. The point is point charge or unit charge. What amount of work done to bring the point charge from infinity to this point is called as potential, electric potential. What the amount of work it is done on that charge is completely converted into what is the potential energy of this point charge. That is what the amount of work done that is consumed. It is changed into potential energy when it comes here. That is the amount of potential energy, amount of work done. That is alternate definition. That is why amount of work done to move unit positive charge from infinity to point. That is one more important, without acceleration. That is, the point is to be moved carefully without any acceleration or deceleration with uniform velocity. What amount of work done is called as potential, electric potential at this point. This is different at different points. If you take any 2 points in the electric field, that is one point, electric potential at one point, electric potential at that point, the difference is called as potential difference. Look at the difference, potential, potential difference. Potential for a point, potential different for 2 points. So there is a different points, you have different potential. Difference is called as potential difference. So potential difference in terms of W meant amount of work done per charge bringing from one point to other point. That is also other way of definition for the potential difference. So that is what the potential we have defined. So electric potential that is defined at this point in terms of this mathematical expression. So all these terms are defined by mathematical equation. F is equal to, at this point, just concentrate, electric field is there because of this. At this point, what is F? At this point, what is E? At this point, what is V? You can understand. All is defined, the terms, mathematical definitions. It is a system containing only one charge. If the system containing many charges, suppose your charge have taken 3 charges. If the system containing n number of charges, and there is also electric field in the space, but electric field is different because of these charges net, that is net electric field is there in this space. In that space, if you are talking about a point, any point, this is the point I am taking this point of study. At this point, we can able to estimate what is, we can able to write the definition or estimate all these quantities. What are the quantities? Like this. This is for a single charge, this is for a multiple charges, space containing multiple charges. We can able to estimate at this point what is the electrostatic force, electrostatic field, electrostatic potential. So that is what we need to understand. Same concept is extended to this. What is the concept? Here, what the charge experience on this point, it is same in accordance with this. what is the magnitude of the quantity, that is force or field or potential at this point by this charge, that is because of the charge. It is from the same concept. So this effect, what is the effect by this charge on this point, whether it is force or field or potential, it is not affected by the presence of this, presence of this. It is independent of the presence of any number of charges, any nature of charges in system. That is why it is always independent. So this also, what is that? This has some, this charge will have effect on this point. That is, what is the effect of this charge in accordance with this? This effect is not affected by this or this. Likewise, we have different effects, individual effect. So individual charges have individual effect on this point. That is, the net effect is, what is that? It is a vector addition. Net effect is vector addition of all the vectors if the quantities are vectors. If the quantities are scalar like this, net is, what is that? That is sum of, what is that? Scalars. Sum, that is vector sum or scalar sum. That is why it is called as principle of superposition. That is known as principle of superposition, means it is a vector addition of all the quantities or scalar addition of all the quantities at the point by the effect of all charges in the system. Is a vector addition or scalar simple addition. The net effect on a particular field, net effect on this particular point is vector addition of all the effects and scalar addition of all the effects. That is effects by individual charges. That is one effect, other effect, that is three effects. If one more charge, four effects, like this. So in accordance with this principle of superposition, if you do the calculation vector addition, so vector addition is force at this point because of this charge is F1 vector. Force at this point by this charge is F2. Force at this point by this charge is F3. Here of course here positive charge is a repulsion. Here positive charge is a repulsion, but negative charge of course is the attraction. That is a force like this. The resultant, that is a point at this point, resultant of these forces is sum of the vectors like this. Then it will take plus or minus depending on the direction of force. Net force, resultant force on this point is sum of the vector addition of this. These are three resultant of this. Similarly, what is the electric field at this point because of these charges is vector addition. That is vector addition of this electric field. That is electric field at this point by this Q is E1. Electric field at this point by this charge is E2. Electric field at this point by this charge is E3. That is vector addition of all these quantities. So direction will be different, like this, direction like this. Direction is like this for this. These two, this is like this. So net or resultant electric field at this point is this. And we know that what is F1 substitute for this. There is a 1 for this using this. Electric force. Here electric force between these two. Electric force between these two is electric force by this charge, like this. Here charge, that is a direction indicates, that is R1 is a distance between them, R2 is a distance between this and that, R3 is a distance between this point and this. That is why it is R, unit vector, and that is square, that is different distance between the point and the charges. In according to the Coulomb's law, that is the one is substituted sum of these. That is vector addition of the resultant force. A resultant field is this. Substitute for this using this. The charge is Q is here, R1, Q2 by R1. Unit vector. Like this. So that is what is the sum This sum, vector sum, is the resultant electric field at this point. This vector sum is a resultant force at this point. That is called as principle of superposition. Similarly, we have potential. It is not a vector, it is a sum of the scalar additions. What is scalar addition? Net, what is that potential at the point, because of all these charges is V1 because of this, V2 because of this, V3 because of this. These are the values for V1, values for this is for the definition. For Q1, Q2, Q3 like this. This is the sum of the scalar vector is a net potential at this point. Look at that. This value, what is that I'm talking about? This value is more than or less than this, depending on the plus and minus charges. So now it is a vector addition, the resultant, or this, that is always this point is a resultant of all the vectors or scalar. This point, if the charges are multiple charges in the system, it is called principle of superposition. So this is only a system containing single charge. From this definition, these definitions are extended to multiple charges in the same way. So in this, what is the interesting point is that this effect is not affected by this effect. That is called as principle of superposition. That is what is an individual sum, that is all. It is called as principle of superposition. This is used in electric field to calculate what is that. These are the quantities need to be calculated at every point in the electric field containing single charge or multiple charges. That is very important mathematical definitions and this concept to understand the electrostatics subject. Thank you very much.